Newton's second law is something that you already know from your physics classes. In chapter 3, we are going to study this law again and also use it in different coordinates to solve different types of problems. So in general, if you have particle and maybe a bunch of particles with some forces on it like F1, F2, anything, F3, then sum of these forces is going to be equal to mass times acceleration, the mass of this particle times acceleration of it. And you should note that this is a vector equation. It means you can write this equation in any direction you want. You can split this in x and y direction, for example, and write sum of the forces in the x direction. The components of all the forces in the x direction, if you add them together, is going to be equal to mass times acceleration in the x direction, or x component of the acceleration. Sum of the forces in the y direction is going to be equal to mass times acceleration in the y direction. If we have z direction, you can write the same thing in z direction. But x and y, you can choose it in any direction you want. Or in general, sum of the forces in any direction is going to be equal to the mass times acceleration in that direction. For example, if you want to use normal tangential coordinate, let's say this particle is moving on a curve, this is going to be your tangential direction, and normal direction is going to be this. You can write some of the forces in the tangential direction, which means components of all the forces in the tangential direction. If you add them together, it's going to be equal to the mass times acceleration in the tangential direction. Sum of the forces in the normal direction is equal to mass times acceleration in the normal direction. Just to remind you from previous chapter, acceleration in the tangential direction is equal to change in the speed with respect to time, or v dot. And acceleration in the normal direction is equal to velocity squared divided by radius of curvature. Or if you like, you can use polar coordinate. In polar coordinate, you can add all the forces in the radial direction, or in other words, find the components of all the forces in the radial direction and add them together. It's going to be mass times acceleration in the radial direction. And in the same way, sum of the forces in the theta direction is going to be mass times acceleration in the theta direction. And again, just to remind you, acceleration in the radial direction is r double dot minus r theta dot squared. And a in the theta direction is r theta double dot plus 2r dot theta dot.